All right, good morning, Pre-Calc. Welcome to section 10.5, Parabolas. So today we're going to focus with parabolas that have a vertex at 0, 0. So we'll look at x squared and negative x squared open up and down, and we'll look at y squared and negative y squared, which will open right or left. So we're going to determine and use the general form of equation for parabolas and graph them. That's our plan for today. This picture here will be on your note packet, but just a couple things here. The definition: parabola is a set of all points that are equidistant from a particular line, the directrix, and a particular point, the focus. So this line down here is the directrix, and this point here is the focus. They are both the same distance from the vertex, and every point on this parabola is the same distance from the focus as it is from this directrix, and that's true on both sides. That's why they have symmetry. This line that goes through the vertex, that's called the focal axis. We know it from geometry and from algebra as the axis of symmetry. You know what the vertex is. That's the point where it opens up or down or left or right from. And then the focal length, that is the distance from the focus to the vertex. And the focal width would be the distance straight across here. So there's a better picture of that in the next slide we'll get to. So here you go. So again, here's our vertex. This distance, when we get to our equation, the distance from the vertex to the focus is p units. It's also the same from the vertex to the directrix. So these two are equidistant. And this focal width is 4 times that value of p. So if we know the value of p, we know the width of this parabola right there through the focus is 4p. Again, we'll get to that in a moment. As you can see, x squared, that's going to be your up or down. If you have y squared, that's your left or right. Okay, we are going to start with x squared here, and what you're going to see today is this standard equation. Don't worry about this up here. That's when it's all multiplied out. We're not going to mess with that right now. So standard equation is right here. X squared equals 4py. Remember, 4p, that is the focal width right there. So whether it opens up or down is dependent on whether or not this number is positive or negative. So if this was 8y, it's going to open up. If it was negative 8y, it's going to open down. The focus, as you can see in this one here, is at 0p, and then the directrix is going to be negative p, in the opposite direction here. So if this was 0, 3, this would be y equals negative 3. If this was 0, 5, this line would be y equals negative 5. The axis is the y-axis, or x equals 0. That's our axis of symmetry. Again, our focal length, the distance from the focus to the vertex, is p units. And the focal width is the absolute value of 4p. So again, if this number is negative, you just take the absolute value of that, but that's going to be the width straight across here through our focus point. So that is for x squared. The next slide, you're going to see very similar deal is going to be for y squared. So now when you have y squared, it's going to be left or right. Again, if this number is positive, we are going to go to the right. If it's negative, it will open to the left. Now the focus is on the x-axis, so instead of 0p, it's going to be p0, so 30 or 50, whatever that number happens to be. The directrix will be on the opposite side. So if this was 40, our directrix would be x equals negative 4. If this was 70, our directrix would be x equals negative 7. Again, they are the same distance from the vertex. Now our axis of symmetry, or focal axis, is the x-axis, y equals 0. So now we're opening up to the left and right. The focal length, the distance from the vertex to the focus, is still p units. And the focal width is still the absolute value of 4p. And that's the distance straight across the parabola through the focus. All right, a couple examples here. So it says find the focus, directrix, and the focal width of the parabola, and they give us this here, negative 1/2 x squared. Okay, and then if we solve this for x squared, we would have to multiply by negative 2, and so that's how we got to right here. X squared equals negative 2y. because we want to get it in this form. So I just multiplied everything by -2 and got to here. So we know that 4p equals -2, and p is -1/2. So my focus, since this is x squared, is going to be 0, -1/2. The directrix is going to be the opposite of that, so y equals 1/2. And my focal width is 4 times that. We're going to take the absolute value, which is 2. So because this is a negative, this parabola would actually open down from 0, 0. Focus at -1/2. The directrix would be at +1/2, horizontal line above it. All right, second example here. Find an equation in standard form. The directrix is the line x equals 2. The focus is at -2, 0. All right, so the directrix is right here. Let me just slide this down a tad. The directrix is right here at x equals 2, which means the focus has to be the same amount of units, 2 units in the other direction right there at -2, 0. So that tells me that p is 2. It's opening left, so that's why we know it's negative. And 4 times that would be 8. So we know this width is 8. So I can go up 4, down 4. That's how I know these 2 points. But here's our equation. So we know that 4p is 8, but again, it's negative because it opens left, so -8x. And again, that should be y squared. Let me go ahead and fix it. All right, now that's correct over here. It should be y squared equal to -8x. And again, negative because it's opening. Parabola is always open towards the focus, and since the focus is at a -2, then our equation will be -8x. All right, find the vertex, focus, directrix, and focal width of this parabola. So again, we have x squared. This is a positive number, so we know this is going to open up. All right, since it opens up, we know that 4p equals +10. If I divide here, p is 10/4 or 5/2, 2.5 if you will. So our vertex, always at 0, 0 for today. Our focus is going to be 0, and then this number, so 0, 5/2. The directrix will be opposite sign, so y equals -5/2. And our focal width, we know that this number is 4p, so our focal width is 10. So if we were going to graph this, it would have a vertex at 0, 0. It would open up. Our focus would be at 0, 5/2. Our directrix would be at -5/2. If the focus was negative, then the directrix would be positive. So they're always opposite sign. Okay, y squared equals -12x. So what we know with this one, because it's negative, is it's going to open to the left. Again, they're not asking us to graph this one at this point, but vertex at 0, 0. We know that 4p equals -12. So p is -3. I don't know what I was thinking right there. -3, sorry about that. So our focus is at -3, 0. The directrix is at +3. And our focal width is 4 times this. Remember, take the absolute value, especially if it's negative. So 4 times 3 would be 12. Okay, find an equation in standard form of the parabola that satisfies these conditions. You're going to see a lot of these on your homework today. You do not have to draw the picture. I just drew it to help out. So we got a vertex at 0, 0. We got a focus at -5, 0. So since my focus is on the x-axis, I know I have y squared. So this one is going to open towards the focus, opening left, which means my directrix is at -5. And if I know p is 5, 4 times that is 20, but it has to be negative because it's opening to the left. So again, you don't need a detailed picture. As long as you know where the vertex is and the focus, you have an idea whether it's opening left, right, up, or down. Parabola is, again, always open towards the focus, away from the directrix. All right, now we got a vertex at 0, 0 and a directrix at y equals 8. So if the directrix is here at +8, then the focus is down here at -8. So we're going to take 4 times that, which is 32, but again, opening down, so x squared is -32y. Opens down, it's negative. If it opens up, positive. Similar idea, vertex at 0, 0, directrix at x equals negative 7. So now we have y squared. Focus is going to be over here at positive 7, so opening to the right. So that's going to be a positive value, 4 times 7, 28. So y squared equals 28x. And again, you don't have to draw the picture, but I always think the visual helps, so you know you've got it opening the correct way, up or down or left or right, so you know you have y squared or x squared correctly. All right, this one tells us we're opening to the left, so we know we're going to have a negative here in front of the x value. So vertex at 0, 0, it opens left. The focal width is 18. So we know that 4p is 18. In fact, it's going to be negative 18 because opening left. And so that is our equation. Y squared equals negative 18x. Again, you don't have to draw this picture. This is just a visual. Remember, if the whole thing is 18 across, then from here to here is 9. And from the focus this way is 9. All right, vertex at 0, 0, and this one's opening downward, so again, it'll be a negative. And we know the focal width is 14, so we know 4p equals that. So if we divide 14 by 4, we get 7 halves, or 3 1/2. Again, negative because it's opening down. So when I take 4 times negative 7 halves, it'll be negative 14. So negative 4x squared equals negative 14y. Y squared equals negative 44x. So again, we know that's going to open left. I gave you a fairly detailed picture this time just so we have an idea, but again, you don't have to do that. If 4p is negative 44, then p is negative 11. That just tells me that my focus here is at negative 11, 0. The directrix is at positive 11. The focal width is 44, so 22 up, 22 down from the focus. And again, because this is negative, it's going to open to the left. Okay, x squared. This one's positive, going to open up. So if 4p is 56, p is 14. So you see the focus is 14 up. The directrix is 14 down. Focal width is 56, so 28 to the right, 28 to the left. And then here is our, again, vertex, always at 0, 0 today. Focus at 0, 14. Directrix at y equals negative 14, and our focal width is 56, which was straight from our equation. All right, that concludes our notes today for day 1 of section 1, so you should be all set to do your homework. There's a completed version of these notes online if you like that version. Otherwise, there's a blank version if you want to go back through and fill them in with this. That works too. So, all right, have a good day.